Hey everyone, it's Adam Small. Good morning. I hope everyone's doing great out there in the heli world. I'm here in my heli hut, as my wife likes to call it. It's May 29th, 2026. Today I'm going to go over some more advanced things in servo setup with Rotorflight and the main rotor geometry setup in Rotorflight, and then the typical tail rotor geometry setup in Rotorflight. I'm going to be working on my OMPM5 today. It's been flying great. I already replaced the servo arms, but earlier, before I recorded most of the videos, I had old servo arms and I replaced them to some SAB ones. Uh, the kit does come with metal arms, which I'm not a big fan of. I'm sure they're great, but hey, every once in a while I pile one in, especially at a fun fly, and I don't want to replace servo gears. So I have SAB horns in there already, but before most of these videos were recorded, I had old arms. Specifically, today in rotor flight, I'm going to be going over set and scale negative and scale positive. And before we even do that, we're going to center our servo scientifically with a protractor. And of course, setting the correct frequency and the speed, which is typically off the specs of your servo manufacturer. Um, but sometimes specs lie. So in later on in the video, I'll go over on setting the correct speed. Uh, as far as the mixer tab, I'm going to go over most of the stuff that's been covered in other videos, but I will do a full setup here on the mixer tab, and I get into collective geometry correction, and I also get into positive collective tilt correction and negative collective tilt correction. All right, stand by, and I hope you enjoy the video. Okay, so right now I have the USB cord plugged into my computer, and the Rotorflight configurator is opened up, and the other side of the USB cord is plugged into my Rotorflight unit. Before we connect a flight pack and power up the servos, we really want to set up some basic settings, specifically the frequency. So right now, I'm in the servos tab. We got servos 1, 2, and 3. Those are the cyclic servos. Servo 1 is the rear servo, elevator servo. Servo 2 is the left cyclic servo. Servo 3 is the right cyclic servo. Servo 4 is the tail servo. My cyclic servos use 1520 pulse. So I have center set up to 1520, and I think that's the default. The min and max, minus 700, plus 700, that's good. Scale negative, 500. Scale positive, 500. And then the frequency I want to run is 333 hertz. Some cyclic servos can run more. You could set that. Some servos also use 760 pulse, so you would change this to 760. As far as speed, you need to look at the specs for now. I'm going to show you a little trick later on where we're going to adjust the speed so the swash ball doesn't jump when I go -9 on pitch to +9 on pitch. But right now, I'm going to set my default setting off my spec sheet for these KST servos, and I think it's 0.75 seconds per 60 degrees. So 0.75, I'm just going to put 75 for all 3 cyclic servos. Reversing, we'll get into that a little later because we actually have to plug in a flight pack to see if we need to reverse that servo so it goes in the appropriate correction. Geometry correction, for all cyclic servos, I select geometry correction to on. All right, let's go to the tail servo real quick. It's a little bit different. My tail servo runs 760 pulse, so center is 760, and then instead of min of minus 700, I need to change it to minus 350, and max, instead of 700, I need to set a positive of 350. And then as far as the scale negative on the tail, Instead of 500, I need to cut it in half and set 250. Scale negative 250 and scale positive 250. Frequency. I want to run my tail servo at about 500 hertz. Some guys run these quite high, up to 1,000 hertz. I select mine to 500. Okay. No need. We'll get into whether we need to reverse the tail servo a little later. And geometry correction, we don't need that on for the tail servo. We also don't need to set the speed for the tail servo like we did for the cyclic, because it's just an independent servo. It's a standalone servo. These, we'll see there's an interaction here between the three servos. That's why we want to set a speed. And then we'll just click save. And since we're changing the frequency, it wants us to save and reboot. Okay, so now that we have the basic setup on the servo tab in the Rotorflight configurator, specifically you want to make sure you got the right rate or hertz set up for each of the servos. I plugged in my flight pack now, and right now I have my rear elevator servo right here, and this is the way the servo arm needs to be on my particular servo. It's going to depend on your model, of course. And I have a whole pile of SAB servo arms here. So basically, I went through my pile of servo arms and I plopped on a servo arm. I picked one that gave me closest to 90 degrees right now. And once again, I do have enable servo override set up on the servo tab. You can see that right there. Enable servo override. It affects the tail servo, but I just like to enable it when I'm setting up the cyclic servos. So I picked out a servo arm that's closest to 90, and now I'll show you my little handy dandy tool here, and a lot of people use this. I got this idea from the Rotorflight website. Pretty much this whole video is basically a summary of the Rotorflight website, and I'll have a link on that in the show notes. So I ordered this protractor. It's a small protractor on Amazon. I'll have the link in the show notes. And basically, I cut the protractor in half, so it's just left of the 90-degree line. So, because I want a 90-degree line, and I want a 0-degree line, and all the degrees between. But basically, I just marked a straight edge, and then I just kind of used a sharp X-Acto knife to cut along that straight edge. And it took several minutes, and then I also cut on the back side, and then I just started wiggling the opposite side of the protractor, and eventually it just cracked off nice and neat. And you can see here you have to drill a hole, and you want to drill the hole. You probably want to use a pilot drill bit and drill right where the 90-degree mark meets the 0-degree mark. And it's about 3 millimeters wide because the servo arm screws are 3 millimeters wide. This is I think a 3x10 M3x10 servo screw. It needs to be extra long, longer than stock, and this is just for setup. So just go in your spare parts and find a longer, like a M3x10. And we're just going to screw this into the servo arm all together. And you don't want to screw it too tight. You just want it a little bit snug because the protractor is cheap plastic. And then right now, I'm just going to line up this 90-degree mark. So it's going right down the middle of these 3 holes here. So right now that's pretty lined up. And then the next thing I do is, this is actually from Twisted Hobbies. It's just a little 90-degree tool. And then I'm just going to lay that flat on the servo casing and see how well it's lined up. And it looks like I need to tweak the servo arm a little bit that way. So to get that little Twisted Hobbies 90-degree tool lined up with the 90-degree mark on the protractor, I adjusted my center to 1514, and they're lined up perfectly. And I'll just show you real quick. So right now the protractor, the 90-degree, is going straight down the servo arm. It's pretty easy to see in real life. And then when I lined up my 90-degree tool, this 90-degree mark is lined up with the 90-degree tool. And then I'll just click save here. Okay, so we just centered our servo. So our servo arm is very, very close to 90 degrees, which will give us a good setup. You always want to have a good mechanical setup before we start tuning. The min and max, I'm not playing with that unless I have binding. Scale negative and scale positive. So that's what we're going to work on now. Basically, we want to teach Rotorflight what a 30-degree deflection is on the servo. So down here, we're going to make sure enable servo override. And then this is servo 1. It's enabled. And I'm just going to go to 30 degrees. You're going to see the servo arm. Rotorflight just moved it what it thinks is 30 degrees. And then I'm just going to use my 90-degree tool, lay it flat against the case, and see how close it deflected 30 degrees. I'm looking at the 60-degree mark right there. So from 90 to 60, that's 30 degrees. And it looks like it may have traveled a little too much. So I'm going to adjust this a little bit. And we're adjusting the scale positive. And let's double check it. It's a little close, but not quite lined up. So I'm adjusting the scale positive. I was at 500. Now I'm at 522. Okay, that is perfectly lined up. So scale positive, I'm at 529, and I was at 500. So now I'm going to adjust to scale negative. So I just moved this slider to minus 30. And this is where it gets a little more tricky. I'm actually going to have to take the screw out and then flip-flop the protractor onto the servo arm. Right now we're doing scale negative, so I have enable servo override. I have the slider set to minus 30. Scale negative default is 500. I'm going to line up my 90-degree tool with the 60-degree mark on my protractor, and it looks like the servo arm didn't deflect enough. So I'm going to increase scale negative. I did this earlier just to save time, and I think 552 increased the deflection of the servo arm, and right now it's lined up perfectly with the 60-degree mark. And I'll click save. Now we need to see whether we need to reverse the servo or not. So this is how the servo is going to be installed on the helicopter. So the servo output is kind of on the bottom of the servo. So if I go to enable servo override and I go to a positive number, the servo arm should move up towards the head. And it does. So I don't need to reverse it. When it comes to the tail, and whether you need to reverse it or not, so let's just scroll down to servo number 4. And when I go positive, the servo arm should move out towards the tail block. It's hard to see, and mine does. So I don't need to reverse the tail servo or servo number 1. Next, I'll do servos number 2 and 3, but I'm going to skip that because you're just going to repeat what I did for servo number 1. Now that we pretty much set up everything we need to do on the servo tab, it's time to level the swash. I like this old school Lynx 700 swash leveling tool. And since I'm enable servo override, all my servos should be centered. And then I'm just going to look at the angle or to see if there's any space between the swash plate and the swash plate leveler. And I looked earlier, and it's handy to put like a white piece of paper behind the swash plate and maybe use a flashlight, and then you may see a little bit of a gap between the swash plate leveling tool and the swash plate itself. I did check this right before filming this part of the video, and miraculously, I think this is the first time this has ever happened, the swash plate is perfectly level. But if it wasn't level and there was a gap between one of these spots here, since we 90'd the servos with our tool and it's pretty exact and scientific, we don't want to adjust the center trim in the configurator or with your servo program box. It's preferred, if these are 90 degreed, the servo arms, to adjust the link to make the swash plate completely level so it's flush against the swash plate tool. Okay, so I put my head block onto the main shaft. I fastened down the clenching screws and then the Jesus bolt up here. And then the next thing, and I'm still on enable servo override in the configurator. So these servo arms are perfectly centered right now. And then I want to look at the angle of the top of the two swash follower arms. This one back here and this one here. And I noticed both were tipped up like this a little bit. So they weren't parallel to the Earth's surface, and this was not 90 degrees here. So it's kind of a pain in the ass, but I took the head block back off and put my swash leveling tool back on, and I shortened each link about 1 millimeter. And then I made sure, of course, the swash is level with the tool here. Put the head block back on, fasten down the clenching screws and the Jesus bolt, and the swash follower arms are all connected and tightened down. And now we can see the tops of both swash follower arms are nice and parallel. Okay, so next step, I do have the head block back on. The swash follower arms are nice and 90'd and parallel. Swash is level. I got the blades on right now, as you can see. And then I have these nice markings on top of the blade grips, these graduation marks. And it's just time to set zero pitch on one blade. So basically how I do that is I just make sure the blade grip, the head block is parallel, lined up with the tail of the boom. And I have this nice Kenny Co version, I don't know, version 2 or version 3 pitch gauge. It's great. And I'm still in Rotorflight configurator here, and I have enable servo override. So right now I have one blade set at zero pitch. So the next thing I'm going to do is I'm going to disable enable servo override, go to my mixer tab, and I'm just going to start from the top here. Under main rotor settings, the default is CCPM 120. That's what I have on my M5. Clockwise rotation, aileron control direction. So let's check this to make sure we're going the right way. I'm going to enable mixer override. I'm going to go to the roll slider down here, and I'm going to go to positive, and the swash plate tilted to the right. So that's correct. And next thing I'm going to do is I'm going to make sure I'm going to get the aileron back to 0. So once again, positive on roll with the slider means the swash plate should go to the right. So that's normal. Elevator, it defaults to normal. So if I go positive on the pitch slider, the swash plate should have tilted forward, but it tilted back. So I need to reverse the elevator control. And now it'll work. So positive number, the swash plate should tilt forward towards the nose of the helicopter. Collective control direction, the default's normal. So if I go up on collective, and the swash plate moved up. So that's correct. Okay, now we're moving down to the main rotor geometry and cyclic calibration. So make sure your enable mixer overrides on, and then on roll, I go to, we'll just start at 0, and then the pitch gauge should be about 0, and it is. If it's not 0, you could just recalibrate level while it's on your main rotor blade. And I'm going to go to roll down here and go to positive 9 degrees. I already adjusted the cyclic calibration. The default is quite low, so you're not going to be anywhere near 9 degrees. So I moved the slider to 9. That should give us 9 degrees of roll, and I have 9 degrees of roll on the pitch gauge. And just for kicks, I'm going to go left roll, so -9. And usually it's never exact. You can see I have about 9.2. That's close enough for me. Okay, so I'm going to go back to 0 on the roll. And now it's collective calibration percentage. The default's quite low. This is with my old servo arm, so let's see how this plays out. So I'm going to go to pitch control. I'm sorry, we're going to go to collective control. We're going to skip pitch because roll covers the pitch. So I'm going to go to 9 degrees. And let's take a look at the pitch gauge here. And it's showing 10.55. So I need to reduce that collective calibration percentage quite a bit. So let me just do maybe 70. I'm guessing it may be kind of close to what my cyclic calibration was. Okay, I'm getting closer. That's 9.35 degrees. So I'll adjust this some more to get to 9 degrees. Okay, so since I had a little less negative collective, about 0.2 degrees, compared to positive collective, I decreased the collective geometry correction to -0.8%, and I brought up the collective calibration percent up a little bit. So now when I'm positive collective 9 degrees, it's 9 degrees, and when I move the slider to -9, it should be equal, and it is. Okay, so our collective control is complete. Let's move on to the next step. All right, on to the next step for main rotor geometry. We just did our collective geometry correction. We set up a collective and cyclic. Now we're going to, you may want to look at your manual. There's a cyclic blade pitch limit. I set 14.5. Collective blade pitch limit, I have a very high of 16 degrees. So once again, maybe look at your helicopter manual. And then total blade pitch limit, usually 22 to 24. I have this model set up to 24. Swash plate phase angle defaults to 0. I don't play with that. Positive collective tilt correction percentage. So this is kind of advanced. You could just make these positive collective tilt and negative collective tilt to 0 and probably get away with it. But since I'm nerding out in this video, we're going to set a positive collective tilt correction. It defaults to 0. I found 10 is a good number on my model. It'll depend on your model. So what we're going to do is make sure we enable mixer override. I'm going to go to collective control, and I'm going to move the slider to positive 15 degrees. So my swash plate just moved up pretty much to its limit that it will do in flight. And then what we're going to do is I'm going to click on the roll slider, and I'm going to use the left and right arrows on my keyboard here, and I'm going to adjust the roll slider, and I'm looking at the very top of the swash ball where it's coming out of the swash plate, and I use a flashlight just to see if that swash ball is moving up or down when I'm increasing my roll. And at the extreme limits, it will move a little bit. So I only go maybe -6 to +6 on the roll to see if that swash ball is moving. And it is not. So that number of 10 degrees works good for my model, but it'll definitely depend on your model. And then you can just go to collective control again and go to -15, and then do the same, repeat the same thing. So increase your roll. I use about plus or minus 6 degrees on the roll, and then adjust your negative tilt correction if you see that swash ball moving up or down on the main shaft. Turns out my negative collective tilt correction on this model was 0. I didn't see the swash ball moving at all. Okay, now that we're pretty much done with the main rotor setup, go ahead and rotate the other blade, the front blade, back over the tail boom, and throw a pitch gauge on there, and then make sure you're in enable servo override or enable mixer override, and then throw that pitch gauge back on that new blade, and then just set 0 pitch with the upper ball link going from the swash plate to the main blade grip arm. There's no need to go through that whole main geometry setup on the other blade. Just 0 the pitch out when the servos are at 90 degrees. Okay, as promised, I was going to talk about servo speed and how it may cause an unwanted jump in the swash plate going from one extreme pitch to another. I think the default for Rotorflight is speed 000 for servos 1, 2, and 3. So let's test this out. I'm going to go to mixer. I'm going to enable mixer override. And then I'm going to jump between 9 and -9 on the pitch slider. And I'm going to watch for the ball to jump. And it may be hard to see in the video, but I'm definitely seeing the ball jump and then go back down. So to fix that, like I mentioned earlier, it's safe just to set your specs speed for whatever servo you have. Mine are 0.075 seconds per 60 degrees. So I put 75, 75, 75, save. And then if I go back to mixer override and I go to pitch, I'm going to go from +9 to -9. And I'm not seeing the ball jump at all, at least with the naked eye. One servo brand I had advertised 0.06 seconds per 60 degree rotation. So I put 60 in the speed for that particular servo, for servos 1, 2, and 3. And I did that test in the mixer override where I went from +9 to -9, and the ball was still jumping. I had to increase the speed on that particular brand of servo to about 100 on servos 1, 2, and 3 before that swash ball wouldn't jump when going from +9 to -9. Safe thing to do is just put in your spec here, and then if you want to nerd out, test it in the mixer override by adjusting your pitch from one extreme to another and watch that swash ball jump. Let's go back to mixer. We talked about, we didn't talk about swash plate trims here. Most modern helicopters have turnbuckles for servos 1, 2, and 3 coming off the servo arms. So we can level the swash by just using the turnbuckles like we did earlier. But if you don't have turnbuckles, you can't fine tune the length of that link. So you could also, if you wanted to level the swash and you don't have turnbuckles, with your swash leveler guide or whatever method you use to level your swash, you could adjust roll trim, pitch trim, and then collective trim. You could use that, to make sure those swash follow arms are 90 degrees. Okay, on to tail rotor settings, and this has been covered by Jonas, Bert, Robert Burrow made a great video. I'm not doing anything advanced from what they're doing. First of all, make sure you enable mixer override. Tail rotor type, it's a variable pitch tail. Yaw control directions normal. Yaw center trim is 0 for now. We're going to change this first. Yaw calibration 30. We're going to increase that. Clockwise yaw blade angle limit 25. Counterclockwise yaw blade angle limit 25. So first of all, earlier when we centered our servos, we 90'd all our servo arms. And then I also adjusted the positive and negative scale on my tail servo here. So I get plus or minus 30 degrees. So Rotorflight knows it's getting 30 degrees. And then the next thing I look at is the tail box here. And I want to make sure this arm here is 90 degrees to this arm. Or this is parallel to this. Right now, mine's parallel. If yours isn't parallel or 90 degrees, then you want to lengthen or shorten your control rod to make it 90 degrees. And you can see there's a little counter torque, which is typical. So nothing to worry about there. So now we're going to go to yaw center trim. And you're going to increase the number so the blades line up. So I know mine's 3.3 because I just did it earlier. Now if I go look at my tail blades, the ends are lined up. They're right in line together. Next thing I'm going to do is the yaw calibration test. We're setting the yaw calibration percentage. Right now it's, I think the default's 30. So this is where you need to use Archie's 30 degree tool. I think I can't remember where I purchased this, but that's the 30 degree tool. Or Robert Burroughs' technique is just to fold a piece of paper like so, and that's a 22 degree tool. So I'm going to go down here. We're still enable mixer override. I'm going to go down to yaw. And since I'm going to use Archie's 30 degree tool, I'm going to go to minus 30. Okay. And then you simply want to put the tool, the 22 degree tool. By the way, if you use the 22 degree paper tool, then set that slider to minus 22. But I'm using Archie's 30 degree tool, so I set it to minus 30. And you can see this angle here, I need to increase the yaw calibration percentage. So there's positive 9. So I'm going to increase this number here to 40. I did this earlier. I know that's perfect. And you can see the tail blades are moving. Now when I put the 30 degree tool on the leading trailing edge of one of the rotor blades, I want to make sure the bottom blade is parallel to the surface. Okay, on to the next step. Clockwise yaw blade angle limit. So I'm going to move this slider to minus 60. And the tail blades didn't move at all. And if I look here, there's still plenty of, I'm not getting full travel here. I can see there's a gap between the tail pitch slider and then the tail box. So I'm going to increase the clockwise yaw blade angle limit. And you can see as I'm increasing the number, the tail blades are moving. Eventually, I'm going to get binding. 40.9 is the number that I worked earlier. And now I can see the sliders all the way against the tail box, and there's no binding. I don't hear the servo buzzing. Okay, now we're going to go to the counterclockwise yaw blade angle limit. So now I'm going to move this slider to minus or plus 60. So counterclockwise 60. And you can see there's just a little bit of a gap there right in here. So I can get more throw on the tail. So I'm going to increase that counterclockwise blade angle limit until that slider can't move anymore. I hear a little binding. I'm going to back it off a little bit. So 28.1. And there you go. That's the tail rotor settings. Okay, one last thing you may want to check after you get your helicopter all set up. The servos tab is all set up. The mixer tab is all set up. And then
disarmed profile 1.
Sorry about that. And then on your rates tab, you have the appropriate rates you want that you're comfortable with. You want to check for binding. So right now, I do have my radio connected to the helicopter. I'm going to plug in a flight pack. And I am plugged into my computer, and I have the Rotorflight configurator turned on. Let me just turn this fan off. There we go, so you can hear. So all my rates in the 3 different profiles are the same. So I'm just going to go low stick. And if we look down here, I'm going to be looking for some binding. You want to look for binding anywhere on your helicopter. So I'm at low collective stick right now. And I'm just going to
fuel 6%.
move the servos. Do a full stir on the cyclic. And I'm looking for any binding on the bottom. Now let's say I did have binding down here. I could go into the servo tab and adjust servo 1, 2, and 3 to a lower number. So for example, I'll just put 500, 500, 500 for servos 1, 2, and 3 for min. And I want it to probably be the same for max. So I'm going to put 500, 500, 500, and then save. And then if we go back and look at the model, okay, I'm at full negative collective on my transmitter, and I'll do a stir, and I can see that bottom or rear servo number 1, the servo arm isn't going down as far as it did before. I didn't have any binding, so I'm just going to go back to min and max of minus 700 and plus 700. But if you did have binding, that's how you do it. You'd also want to go full collective and also do the same thing, stir the sticks and see if there's any binding. Specifically this rear rod here, it may bind up with the top of the pin guide here.